Okay, so hello guys. So we are now in the third part of the analysis of T-beams. So in the first part, I already discussed the concepts of analyzing T-beams. The second part, we solved an example problem of an SI, na unit na problem. So we used there NSCP 2015 code. So here in this video, we are going to solve another problem, which is an English unit-based na problem. Okay, so I will read first the problem, guys. Now, compute the design strength of the T-beam shown in the figure in which F sub C prime is 4,000 psi and F sub Y is 60,000 psi. So take note, guys, this is English. So we are going to use the ACI 31814 na code, okay? So, ayun, so first, all we need to do is, okay, so dito natin isa-solve, guys, yung ating problem. So we are going to solve it in this board, okay? So first, all we need to do is to list down all the given sa problem. Okay, so of course, the F sub C prime is already given, that is 4,000 psi. F sub Y is given 60,000 psi. B sub F is the effective width, that is 30 inches. H is the thickness of the slab, which is 4 inches. The B sub W is the width of our web, that is 14 inches, and the D is the effective depth, that is 30 inches from the extreme compression fiber, okay, up to the centroid of the steel, okay. So now, first, what we have to do is to check first the area of steel if it satisfies the code requirement. So, ayun, take note, guys, that in the English na unit na system, usually ang given nga is number ng bar. So, we usually give bar number in English na system, English units. So, for konting review lang, we have to review kung paano ba tong pag-treat natin sa mga bar numbers. Okay, so take note na kung number 3 to number 8 yung ating bar number, then we can get first the diameter of that bar. That is, all we need to do is to divide that number by 8. So for example, number 4, yung ating bar, so 4 divided by 8, that is already the diameter in inches. That is 1/2. No, tama ba? 4 divided by 8 is 1/2 inch. So yun na yung diameter for the number 4 bar. Okay? Ayun, so for bar number exceeding 8, that is from number 9, 10, 11, 14, at saka 18, actually, they follow a specific area ng square bar, no? So, pero hindi sila square, guys, no? Let me just clarify this, no? Number 9 above are all circular na reinforcing bars, no? Hindi ito mga square bars. Pero yung kanilang area ay sumusunod sa area ng mga square bar na 1 by 1, 1 and 1/8 by 1 and 1/8, 1 and 1/4 by 1 and 1/4, 1 and 1/2 by 1 and 1/2, and 2 by 2. So, ayun. So, ibig sabihin, guys, for this specific problem, we are going first to compute for the AS, no? Our area of steel, and that will be equal to area of the steel is 1.125 times 1.125. That is actually number 10 man, no? So, number 10 is 1 and 1/8, so that is 1.125. So, square man siya, so that is 1.125 times 1.125. And then, we multiply that by 8 because there are 8 pieces of bars in our T-beam. Okay? So, of course, our area ng steel is 10.125 square inches. Okay? So, now we are going to compare that to the minimum area ng steel required by the code. So, according to the ACI, that is, AS minimum shall be the greater of A and B. So, ayun. So, we need to compute for our area ng steel minimum. Okay, so there are two formulas here. So that is for A at saka sa B. Okay, for the AS minimum A, of course, given, guys, yung F sub C prime, F sub Y, B sub W, at saka D. So lalabas dito, area ng steel minimum A is 1.3282 and the area of steel minimum B is 1.4 square inches. So now we will choose the greater because according here, AS minimum shall be the greater of A and B. So the greater here, of course, is the AS minimum B. Okay, so now we are going to compare that to our actual steel area, which is 10.125. So take note, guys, that the AS natin, that the actual steel area must be greater than the minimum. Kasi ito dapat yung minimum na steel area na required ng code. So ayun, so Okay, so in this case, 10.125 is actually greater than the AS minimum. So that means it already satisfied the minimum na code requirement ng steel area. Okay, so that's it guys. So we now go to our step 2. So according to step 2, we have to compute for the total tensile force, which is T is equals to ASFY. Okay, so I updated our given, okay, list ng given. So AS, I already put here, guys, the 10.125 square inches. Okay, so now we are now going to compute for the tension force, and that is AS multiplied by F sub y. Okay, so of course, AS is already computed, that is 10.125 square inch. And then F sub y is already given in the problem, and that is 60,000 PSI. Take note, PSI is pounds per square inch. So that is why no, our resulting unit will be pounds kasi makakancel nga C inch square. Okay, so our tension force is equals to 607,500 pounds. Okay, so now, no, let's now proceed to our third step. So what will be our third step? So in the third step, we are going to equate the total compression force, which is C equals to 0.85 F sub C prime A sub C, to T and solve for A sub C. In this expression, A sub C is the assumed area stressed in compression at 0.85 F sub C prime. The compression force C and the tensile force T must be equal to maintain equilibrium at the section. So ayun, so I already updated guys the given list. So ayun, so I already placed here the 607,500 na value ng ating tension force. Ayun. So now again, we are going to equate C to T. Okay, then of course C natin is 0.85 F sub C prime multiplied by A sub C. Of course, F sub C prime is given, and that is 4,000 PSI. Okay, so what will happen here? C will be equal to 3,400 multiplied by A sub C. Okay, so we are now going to equate 3,400 A sub C to T. And of course, T is already computed sa taas, and that is equal to 607,500. And now we can now compute for A sub C, which is equals to 178 point. That is 0.68 square inches. Okay, so take note, guys, that this A sub C is the area of the compression concrete. No? So now that we know that A sub C is the area of the compression concrete, we would like to find out if this area ng compression concrete is still on the flange. So we would like to find out if it is located in the flange or if it is located below the flange, or that is already sa may part na ng web, no? Okay? So ayun, so all we need to do first to find out about that, no, is to compute first the area ng ating flange. So the area of the flange is simply 30 inches times 4 inches, and that is equal to 120 square inches. So ayun, so this is 120 square inches, guys. That is the area of the flange pa lamang, no? So now, no, isipin natin. So yung area ba natin ng compression concrete galing sa extreme compression fiber is lalampas na ba siya ng flange papuntang web or nasa flange pa siya? So take note, guys, no, yung ating area ng compression concrete is already 178.68. Pero yung ating area ng flange is 120 square inches lang, no? So in other words, no, lalampas siya dapat ng flange. Okay, so take note, since A sub C is greater than the area of the flange, the compression stress or the compression concrete ng area extends below the flange. So yung compression stress block na A extends below the flange. So all we need to do now, no, since we already find out about that, no, is to compute kung ilan pa yung area na nasa web. So how much area is required, no, para sa area ng compression concrete, no, ilan pa yung area na nasa web. So ayun, so let's compute that value, guys. Itong area na to, let's compute for that value. So area of the web is equals to A sub C minus area of the flange. So that is equals to A sub C natin, or area of the compression concrete, is 178.68 minus area of the flange natin is 120 square inches. So of course, our area of the web is 58.68 square inches. So in other words, guys, etong nandito na natitira sa may baba, no, that is 58.68 square inches. So now we can now compute this depth din, tama ba? depth na to sa may web na area, no, all we need to do is i-divide yung 58.68 sa 14 inches na width ng ating web, and that will be equal to 4.191 inches. Okay? Okay, so para maintindihan natin guys, no, i-drawing natin yung ang ating force system dito. Okay, so we have this tension force. We already computed this value kanina. Okay, so the tension force is located at the centroid of the steel area. Okay, so of course, nasa gitna siya. Then we have this compression force. Take note, yung compression force natin will be located at the centroid of the area ng compression concrete. So take note that since our area ng compression concrete is not rectangular, then this compression force is not located halfway, midway between the extreme compression fiber up to this line, no? Hindi siya dapat located midway, no? That is, located siya at a certain distance, bar sub y ang itatawag natin sa kanya. Okay? So, we need to compute this bar sub y, guys, because kailangan natin siya sa pag-compute mamaya ng VMN. So, yung VMN natin is the couple created by these two forces, the T at saka C. So, kakailanganin natin yung distance nila. Okay? So, that will be, ayun, so kunin muna natin guys yung ating bar sub y. So, using the Varignon's theorem guys, A sub T or total area multiplied by bar sub y is equals to A sub 1 y1 plus A sub 2 y2. So, take note, our A sub T here is the area of the compression concrete. Bar sub y is the centroid, no? Location ng centroid from the extreme compression fiber. A sub 1 natin is the area ng flange, and A sub 2 is the area of the web. Of course, y1 at y2 are both the distances ng centroid ng flanges at saka ng web from the extreme compression fiber. Okay, so let's substitute that, guys, no? Of course, A sub T is 178.68 because that is the area of the compression concrete, no? Then multiplied by bar sub y equals to A1, of course, is the 120. That is the area of the flange. Okay? Multiplied by 2 inches. Y1 natin is 2 inches because that is the location ng centroid from the extreme compression fiber. That is, yun na nga, no? 4 inches man tong thickness ng ating flange. Okay? Plus, 58.68 is the area of the web. Plus, of course, the location ng ating centroid ng area sa web from the extreme compression fiber, or that is 4 plus half ng 4.191. Okay? So, I hope you understand that, guys. So, now we can now compute for the bar sub y, and that is 3.345 inches. Okay? So, now, no, since na-compute natin, guys, si bar sub y, we can now compute for the value of the distance between tension force and the compression force. That is the value of Z. Okay? So, Z here is equals to D minus bar sub y, of course. Okay, so D is already given, that is 30 inches. So D natin is the 30 inches, this one. So Z is equals to 30 minus 3.345 inches. Okay, so of course, our value ng Z is 26.655 inches. Okay? Okay, so let's now proceed to the next part of our solution. Okay, so we have now, again guys, no, yung Z dito is kakailanganin natin mamaya sa pag-compute nga ng ating VMN. Okay, so ayun, so let's now proceed to our step 4, that is to calculate the tension strain including the A and C. Okay, classify whether tension controlled, transition, or compression controlled, and then solve for phi. Okay, so ayun, so I have already updated guys the given. So nilist ko dito sa A sub S, we already computed that. Okay, so tension force, bar sub y at saka Z, and then I already included si A. So take note, A is from extreme compression fiber up to this line, that is 4.191 plus 4, that is 8.191. Okay, so now, no, for us to compute for the tension strain, all we need to do is to draw the tension diagram, the strain diagram. So ito yung ating strain diagram. So again guys, no, I'll just explain this ng pahapyaw, no. 0.003 yung ating maximum na strain ng concrete, and our tension strain is unknown. So ito yung kino-compute natin in this part. So of course, from here up to here, that is the effective depth, and the part where the line crosses the vertical line, that is actually the neutral axis, no, and that is C. Okay, okay, so now, no, let's use this triangle, that's the yellow triangle, and this smaller triangle so that we can create a ratio and proportion na equation. So that is the big triangle, guys, that is the tension strain. This side, tension strain plus 0.003 is to this side, that is T. Okay, itong side na yun, guys, na vertical. Okay, is equals to this smaller triangle. This side, 0.003 is to this side over C. Okay, so yun na nga, guys, itong ating equation na to. Okay, so we can compute. Okay, so again, take note that the D is already given, that is 30 inches. Okay, so now we can compute for the C, that is equals to A over beta 1. So of course, A is already given. I mean, na-compute na natin yung sa A, that is 8.191. We need now a value of beta 1. Okay, so take note the beta 1 is located sa table 22.2.2.4.3 in ACI 31814, and according to them, no, it depends, the value of beta 1 depends on the value of f sub c prime, and our value of f sub c prime nga is 4,000 psi, so it means our value of beta 1 is 0.85 because it is equal nga to 4,000 psi nga yung ating f sub c prime. Okay, so again, no, we can substitute now. C is equals to, again, A natin is 8.191, or that is 4 plus 4.191 divided by 0.85. So our value of C is 9.636. So now, no, if we substitute this value ng C in our equation, we can compute for the tension strain, and that is equals to 0.00634. Okay, so that is the value of our tension strain. So now, no, let's analyze this value of tension strain. So we are now going to classify our T-beam if it is tension controlled, if it is transition, or it is compression controlled. So ayun, so our tension strain nga is 0.00634. And take note, according to table 21.2.2 of our ACI 31814, no, if the tension strain, we can classify the beam, no, according sa value ng ating tension strain. If it is less than or equal to the yield strain, it is compression controlled. If it is between the yield strain and the 0.005, it is transition. And if it is greater than or equal to 0.005, it is tension controlled. In this case, our tension strain is 0.00634, and it is greater than or equal to 0.005. So it means we are going to look at this part of our, at this row of our table. Okay? So of course, no, ang titingnan natin, guys, take note that this is tension controlled. Okay, again. And para sa value ng ating phi, of course, that will be equals to 0.90. Saan yan makikita? Of course, dito, guys, no? Kasi take note na itong part ng ating table is for transverse reinforcement. And since we do not use the spiral for beams, okay, dito tayo sa other, no? For beam, T-beam man to. So this is phi is equals to 0.9, okay? Ayun. So now, no, that we have computed our value ng phi, then we can now compute for our value ng ating design strength ng ating T-beam. So what we are now going to do, guys, is to compute for our phi mn. Okay? So ayun, so I have already updated our list of given here. So I already placed here the tension strain and the phi. Okay? So ayun, so again, guys, our phi mn is the moment created by these two forces, the T and C, and that is this moment, which is, we call that as the nominal moment, or Mn, no? So we are going to compute for the phi Mn, so that will be, i-multiply natin yung value ng phi sa Mn. So take note that, okay, phi Mn natin, guys, take note, Mn is the force multiplied by the distance between them. Take note that T and C here are equal. So, isang force lang yung gagamitin natin. So, take note that T nga is ASFY. Diba? Tension force is ASFY. So, tension force itong nandito multiplied by the distance between them, that is Z. Okay? So, of course, we can now substitute our values. 0.9 yung ating phi. AS natin is 10.125. So, we can locate that here, no? And then Fy is 60,000, and then Z natin, we already computed that. Okay, that is 26.655 inches. Now we can now compute our PMN, and our resulting value will be pound-inch. That is 14,573,621.25 pound-inch. Of course, no, usually in kapag English yung problem, hindi pound-inch yung nire-require sa mga problem, kundi keep feet, no? So, ibig sabihin guys, if we convert this to keep feet, this will be 1,214.47 keep feet, and that is already the design strength of the T-beam. So, ayun guys, no? So, I hope you understand the process of the solution. Ayun. So, madali lang naman actually guys itong problem ng T-beam sa analysis, no. So take note, the answer here again, let's just review the VMN, which is the design strength of the T-beam is 1,214.47, that is in keep feet, and that is the design strength of the T-beam. So I hope you understand guys our lecture. So please don't forget to like and subscribe to my videos, ayun, to my channel. And if you have any questions, you can email me and you can message me in Facebook. No, I am recently kay nabibisi ako, so hindi ko masyadong masagot guys yung ating mga tanong sa email. Lalo na sa email, ang dami mga tanong. Sa Facebook walang masyadong nagtatanong. Baka nahirapan kayong maghanap ng aking Facebook account. Basta may professional account na nakasulat guys, no? Yun na yung aking Facebook account. Okay, so that's it guys. So I hope na magkita-kita pa tayo sa ating next na mga tutorial videos sa reinforced concrete design. So ayun, so hanggang dito na lang guys, and bye-bye!